Hello guys, welcome to my second class of module 5. Now in this case we discussed in the previous video, suppose the given matrix is a symmetric matrix, how to diagonalize. Diagonalize means we are doing ortho diagonalize means what we are did. We are taking a matrix, we have to find out eigenvalues and corresponding eigenvector, and then I to all the eigenvectors must be a linear independent. How can you know that? Find out the inner product of all the eigenvectors that give rise 0, then we say that is a orthogonal. Once is orthogonal, then we have to take the normalize of the each of the vector is nothing but columns of P. From that, we have to find out D is nothing but P transpose of the given matrix into P. Yeah, why you are taking P transpose here? Because the matrix is a symmetric, and also once you preparing P is nothing but orthogonal orthonormalized based on the vectors we are preparing a matrix. Therefore, P inverse is equal to P transpose. Okay. The next is actually in the note, observe before I'm moving to the next, you take some more problem, similar type problem, we discuss. If you want, I'll upload it at the end of the my module 5 class, some more problems. Okay. Note. In the note I written, if A is a symmetric matrix, fine, then any two eigenvectors from the different eigenspaces are orthogonal, and n cross n a matrix is orthogonalizable if and only if A is a symmetric. I think that the meaning is, I told this point is already in my previous video. Yeah, all the vectors are linearly independent means what? The inner product of the value must be 0. Then we say that orthogonal. Then n cross n is orthogonalizable means orthogonally diagonalizable. Orthogonally diagonalizable is nothing but if and only if the matrix must be symmetric. Is a symmetric, then vectors are linearly independent. Then we say that the diagonalize is nothing but orthogonal diagonalizable. Okay. Next, I'm moving to the next problem. Diagonalize the matrix A is equal to 3 minus 2 4 minus 2 6 2 4 2 3. Even though I had to convert this matrix in the form of what actually row into the column, row into transpose. You do the transpose means convert row into column, we get a same matrix. Therefore, the given matrix is a symmetric matrix. What we are going to do, first you take a determinant of A minus lambda I, you narrate the characteristic equation. From the characteristic equation you find out the corresponding roots, that is nothing but eigenvalues of the given matrix. That is nothing but what? Eigenvalues of the given matrix. Yeah, you know that how to find out eigenvalues already I discussed in the previous my video. You find out determinant of A minus lambda I, you narrate the eigen characteristic equation in terms of lambda, and then you feed it in your in your calculator, for a V2 based calculator. Then immediately we get the values of lambda 1, lambda 2. I told already. After this step, if you want to do it for the other, directly feed it in your calculator, we get immediately eigenvalues. These are the eigenvalues we get after the write the characteristic equation from the determinant of A minus lambda A. These are the eigenvalues. Okay, these are the eigenvalues. Once we get the eigenvalues, observe carefully in the one we get 3 eigenvalues, but in the previous problem we get all the eigenvalues are independent. They are distinct, real and distinct. 3, 6, 8. But here eigenvalues are, yeah, lambda 1 is minus 2, lambda 2 is 7, lambda 3 is 7. Means 2 eigenvalues are same. Means one eigenvalue is repeated more than once. Okay. Therefore, what we are going to do here, now first you take a first eigenvalue. You write the matrix of A minus lambda I into matrix of X is equal to matrix of 0. You write the system of equation. From this, you choose the two equations. Both the equations are linearly independent. Means one of the equation cannot be written as in terms of the other equation. That is called linearly independent. Using that, you find out the eigenvector. This is nothing but eigenvector of the given the corresponding eigenvalue. What is eigenvalue here? Lambda 1 is equal to minus 2. Now we get this is eigen vector. And next you substitute, but here lambda 2 and lambda 3 are same. Therefore I substitute once lambda is equal to 7. Once you substitute lambda is equal to 7 in the matrix of A minus lambda I into matrix of X is equal to matrix of 0, and then we write a system of equation from this matrix. We get these equations. See, all the three equations are identical here. If we want to divide by 2, first and last equation are divided by minus 2 in first and last equation, we get actually all three equations are same. Therefore, it is clear that all three equations are same. For one equation, we can't find out the what about all unknowns, because three unknowns with three unknowns with one equation. Therefore, how to proceed? Now here, choice of you. I choose two unknown values for k x1, x2, x3, or you choose x1, x2, x2, x3, or x1, x2. Choice of you. Here I choose x3 is equal to k1, x2 is equal to k2. Are you okay? I choose what are the values. x3 is k1, x2 is k2. Okay. Now, or if you want to choose anyway, choose two unknowns for any two vectors, say x3 and x2. Now, I have to substitute these two where in this identical equation. What you have the identical equation 4x1 plus 2x2 minus 4x3. Any one of the equation I have to substitute. We get x1 in terms of k1, k2. In terms of what? K1, k2. You already know that. What I did, I taken k1, k2, two unknowns for x2 and x3. And then x3 is k1, x2 is k2. Then I have to find out x1 in terms of k1, k2. Once we get x1 in terms of k1, k2, what I did now further, I have to give the values of two set of values. K1 is equal to, what about that? K1 is 0, K2 is equal to 1. K1 is equal to 1, K2 is equal to 0, like that. First I am going to substitute the value. K1 is equal to 1 and K2 is equal to 0. First I have to substitute what's the value. K1 is 1 and K2 is 0. 1, 0, 0, 1. That's all. Now, 1, 0 I have to substitute. Now we get, now we get x2 is 1. Therefore, what are the values here? x1 is 1, k2 means x2 0, k1 is x3. Therefore, 1, 0, 1 is a vector. Next, I have to take k0 and 1 because I required two unknowns, right? K1 and K2. K1 is 0, K2 0, K2 is 1. Then we get x1 is half. Half is nothing but actually we get x1 is minus half. This is actually minus half because k2 is 1, we get k1 is 0 minus half. Therefore, x1 is minus half, k2 means 1, k1 is 0. Therefore, these two are vectors we get, okay. This is a way to find out eigenvectors. Suppose they are having a repeated eigenvalues occur in the characteristic equation, okay. Now, we get total, we get how many? Three vectors x1, x2, x3. Okay, then we have to find out inner product of x1, x3. Inner product of x1, x3 is nothing but x1 transpose x3 is depending upon what you have vector. Here vector is a column. Therefore, what we are going to take here a written in the top of that, this column becomes row into column, right? I don't know, transpose, x1 transpose into x2. x1 transpose into x2, multiply that, we get 0. Similarly, x1 into x1, x2 is each x1, x2 is a column vector. I to convert x1 is in the form of, first vector can be written in the form of transpose into what about x3? x1 transpose into x3, we get this. Are you clear? Written in the top, you please try to understand. And x2, x3 means x2 transpose into x3. This is row into column. They will get minus half, 0, 0. What we get? Minus half. This shows that x2, x3 is not a orthogonal. But x1 is orthogonal to x2, x3, but x2, x3 is not orthogonal. It's not orthogonal. I had to convert the orthogonal by using Gram-schematic process. Now, what are the vector is a problem? x2, x3. Therefore, x2 is my v2. Yeah, v1 is the first vector itself. There is no problem for x1. Therefore, I treated v1 is first vector. Okay, what is v2? v2 is nothing but actually, now I am taking v2, v3. I am not taking x1, only I have to take v2, v3. v2 is nothing but x2. x2 is what actually 1, 0, 1. Next, I have to find out v3 based on x2. Don't confuse. Don't take v2 and v1. Here, v1 is separate. v1 is, we are not, that is a orthogonal to x2, x3. Only is a problem for x2, x3. Therefore, I took it v2 for, what about that x2. Therefore, v2 I have to find out only based on V3 I have to find out based on V2. Don't confuse here. We have taken V1 separate. We are going to find out, apply the gram symmetric process based on x2, x3, because these two are what type of vectors? They are not orthogonal vectors. If I treated V2 is x2, I have to find out V3 based on only V2. That's why what's the formula? X3 minus inner product of x3 comma V2 divided by inner product of V2 comma V2 into V2. Why I am not written V1? V1 is not considered that V1 is nothing but x1. x1 is orthogonal to these two vectors. Okay, don't confuse here. Okay, fine. In the next step, then we are going to take next one. Actually, from this, please try to understand this one. Don't confuse this. Why I taken the inner product, the thing. Yeah. Next one is actually. Sorry. 1 minute. In the next one, actually here, this one. Yes. 1 minute. Before moving to the, even though it's time up, but don't worry about that because you want to understand clearly. See, here x1 is separate. You are applying gram schematic process only based on x2, x3. Therefore, V2 is my x2. V3 is only finding based on V2, not for V1. Okay? Yes. I'm moving to the next step. If you want to find out what are the values are required now, inner product of x3 comma V2 are required. Inner product of what actually x2 x3 comma V2 are required. Therefore, I'll write that. But I written here in the right extreme corner. Transpose into what about x3 transpose into V2 written here. Multiply that, we get minus of. Inner product of V2, V2 means V2 transpose into V2. Multiply that, we get 2. You know how to find out inner product value. And then from that V3 I have to find out. What is the V3? X3 minus of inner product of x3 V2 divided by inner product of V2 into x3. Simplify that, we get V3. Now V1 is the original x1. V2, just now we have taken x2 is 101 and then V3 is minus 1 by 4, 1 by 4. Now you find out inner product of V1, V2, V2, V3, V1, V3 definitely 0. Then we say that V1, V2, V3 are orthogonal vectors. Then I have to normalize. U1 is nothing but V1 normalize of V1. U2 is nothing but V2 normalize of V2. And then U3 is nothing but V3 divided by normalize of V3. You know how we get normalize root of what about minus 1 whole square, minus half whole square, plus 1 square, like that you find out the normal value. And then you prepare P. Rest of thing you know how to prepare P. P is orthonormalized vector. Each of the orthonormalized vector of V1, V2, U3 is nothing but columns of P. Then you take P transpose A into P, multiply that, we get a what actually? We get a diagonal matrix. See, observe the diagonal values are what we get the eigen values of the matrix A. This is a way to find out in this problem. Observe in this problem one point. The point of this problem is the given matrix is a symmetric matrix. After once you find out the eigen values, we get two roots are repeated. Same value means one of the root repeated twice. In such cases, how to find out the eigenvectors? What we did, we substitute once. But you don't get it more than one equation linearly independent. I think it's clear what's the meaning of linearly independent because all three is equations same. Therefore, for one equation, 3 unknowns you can't find out. Therefore, what I did, I had to assume 2 unknowns k1, k2 for x3, x2. Give 0, 1, 1, 0, 0, 1. We get x2, x3 value. Find out inner product of x1, x2, x2, x3, x1, x3. But x1, x3, x1, x2 is 0, but the inner product of x2, x3 is not equal to 0. Now these two are not orthogonal. Pick these two, apply gram schematic process to find out new V2, V3. Old x1 is v1, new values for gram schematic is nothing but while applying gram schematic I taken v2 is x2 directly. Therefore v3 finding v3 only I had to find out using to find out v3 based on V2 not for V1. We get V1, V2, V3, new V1, V2, V3. Verify that inner product is equal to 0. What we proceed after equal to 0, what we did here, inner product is 0 means all new vectors V1, V2, V3 are orthogonal. And you are normalized, you take normalized vectors are nothing but columns of P. Now that is orthonormalized vector, therefore this is orthogonal matrix. Therefore instead of inverse, what we take P inverse A into P. You know that in the previous problem, you multiply it, we get carefully multiplied, definitely we get a diagonal matrix with what you have diagonal values in the A. Now this is a way to diagonalize. Suppose the given matrix even though is a symmetric, but what happen is not a orthogonal. I think it's clear everyone. Before moving to the next problem, that problem is okay. Move to the next problem. This problem is a 10th one. Yeah. In this problem, yeah. Please observe in this problem. Sorry, I am searching for the paper. Please give me an excuse because they mix up. Okay. Next, this is another different problem. Please observe from the last video, this video only I discussed two problems. Both the problems are different. But my aim is, suppose I solve one problem also, we are clear, concept is clear, next is easy to solve the problem. Okay. Next, moving to the next one. This type of problem we already solved in your first year B level. A power of n, P into D power of n into P power of T, where A is a symmetric matrix. Suppose it's a symmetric matrix. Some cases, after you diagonalize, they are asking to find out A cube, A power of 10, A power of 100. Suppose A is a symmetric matrix, just use this formula. Which formula to find out the power of A power of n, P into D power of n into P power of T. Suppose A is a not symmetric. There if you want to find out A cube, A power of 10, A power of 100, there I am using the formula is P into D power of n into P inverse. A is not a symmetric, it's a non-symmetric matrix. Okay. Diagonalize the matrix 1, minus 1, 4, 3, 2, minus 1, 2, 1, minus 1 and also find A power of 4. Observe, you change row into column. Is definitely A transpose is not equal to A, therefore the matrix A is not a symmetric matrix. Fine. It's not a symmetric matrix. How to do? Same procedure. First you find out write the determinant of A minus lambda I. Find out the characteristic equation using A minus determinant of A minus lambda I. Once this is a characteristic equation, just you feed in your calculator, immediately we get these three are the eigenvalues. What are the eigenvalues? Lambda 1, minus 2 and 3. Then you take one by one eigenvalue, find out the corresponding eigenvector. While finding eigenvector, please try to understand, choose two equations from the what you narrate the system of equation from the matrix. After you substitute the eigenvalues, you choose two equations are linearly independent. Then we have to find out the corresponding eigenvectors. Are you clear? You find out, say for lambda is equal to 1, lambda is equal to 2 and also lambda is equal to 3 to find out the eigenvectors. Why I am going to skip that? You know how to find out the eigenvectors. That's why. Don't feel bad here. Now, but while finding the eigenvector, again I am going to repeat, choose equations. Both the equations are linearly independent. Means one equation cannot be expressed in terms of the other. Fine. Once we get the eigenvectors, we get x1, x2, x3. Now the given matrix is not a symmetric matrix, therefore I'll take directly P. P is nothing but columns of the eigenvectors. The columns of the eigenvectors. First lambda is equal to 1 eigenvector, lambda is equal to minus 2 eigenvector, lambda is equal to 3 is eigenvector. You find out P inverse. This is a lengthy process. How to find out P inverse? You know that. Now how to find out P inverse? You take P and then take simultaneously after the splitting the identity matrix of the same order of P. Using elementary row operation. See, observe the first chapter, how much very important. By using elementary row operation, you convert this P, whatever left hand side P, in the form of identity matrix. To convert P is in the form of identity matrix means is convert into row reduced echelon form. Except pivotal element, the rest of the element are 0. and the pivotal element must be 1. That is nothing but identity matrix by using elementary row operation. First keep the first row first element, convert the rest of the values in the second row, third row 0. Move to the second row, second element must be a non-zero value, fix that, convert the following the values are 0. This is echelon form. After you convert echelon form and then you convert, this is pivotal element must be 1. Means fix the third row, convert the above of the third column, second, the first row value must be 0 by using elementary operation. You go back, fix the second row, third row. And next fix the second row, fix the second element is an pivot element, convert the above the values as 0. Then until reach the first row, then automatically is converted into identity matrix. Instead of original identity matrix, what we get the matrix is nothing but inverse of the corresponding matrix. What's the corresponding matrix here? P. Once we get inverse, and then I have to apply the formula. We already discussed this formula in this my video. What is the formula? P inverse of A into P. Yes, P inverse, you know that you keep, say at a time you can't multiply all the 3. What I did, I keep P inverse as itself. I had to substitute E and P. Multiply it. While multiplying that, we get this is a resultant matrix. While writing a resultant matrix, I am going to enter P inverse. At a time writing all the 3 matrices, wasting a time, we don't have a much time to solve. That's a, what about another drawback for this. Even though it's a problem, it's a very confident to score the marks, but must be practice, and also I have to solve a little bit quick. Okay, but you can't do the mistake. Suppose you do one mistake, definitely you don't get it correct answer. That's also another one drawback. Yeah, first you substitute A and P, multiply it, while writing a resultant simultaneously substitute P inverse. Then multiply that, automatically we get what actually is converted into which matrix. What about the which matrix we get actually? We get a what actually diagonal matrix. In the diagonal they are having a eigen values of the corresponding A, 1, minus 2, 3. Yeah, I want to find out A power of 4. How to find out A power of 4 in this case? P into D power of 4, P inverse. Just you take a D power of 4 means 1 to the power of 4, minus 2 to the power of 4, 3 to the power of 4. That's all. Then just you have to take to the power of 4 in the diagonal. That's a way to find it. Then you multiply what about that diagonal? D into D power of 4 into P inverse. Yeah, this is ulta. This is P inverse here. While finding a power, P inverse comes first, P comes last. D power of 4 into P inverse multiply and then resultant multiplied with P. We get this is A power of 4. This is a way to find out A power of 4, A power of 10 or like that. Is not a symmetric matrix. How to find out A power of n is nothing but P into D power of n into P inverse. Instead of finding D power 100, this is the easiest way to find out the value. Now, you already solved such type of problem where in your first year linear algebra, in spite of that I discussed. Totally from last and this video, I discussed 3 problems. Again, I'm going to, before going to end up this class, I'm going to revise these 3 quickly. The first, suppose the given matrix is a symmetric matrix. How to diagonalize? First, you find out in all 3 cases. First, you write is not a symmetric, is a symmetric in both the case. First, you have to convert the given matrix must be determinant of A minus lambda I equal to 0. You narrate a characteristic equation. Once you get character, you find out the eigenvalues. Once we get the eigenvalues, you find out the corresponding eigenvector. Once we get while finding eigenvectors, you choose the system of equation. Both the 2 equations are linearly independent. Such type of thing use, and then you find out. Once you find out that, and then you have to find out inner product of x1, x2, x3. All are inner product of all are 3 are 0, then we say that orthogonal. Then is orthogonal, then you take the columns of P1, P is nothing but V divided by norm of V1, V2 divided by norm of V2, V3 divided by, you take the columns of normalized columns vectors. That is our orthogonal matrix. Then we have to write what actually P transpose into A into P. Then you multiply that. No need I to take P inverse here. Just I to take a P transpose, because the given matrix is a what actually? Given matrix is a symmetric matrix. I told already that point. Okay. Just I to P into what about that? P transpose into D into P. Yes, D into P multiply D transpose. Then I have to take it in E, D. That is A. Finding D means we get ulta. P transpose into A into P. What's the formula? P transpose into A into P. P transpose into A into P, multiply that, we get a diagonal matrix. Then we get cross check whether we get a diagonal matrix. Diagonal values must be a eigenvalues. Okay, fine. Next, suppose the given matrix, even though it's a symmetric matrix, any two roots are equal, repeated roots. In such cases, definitely you don't get it linear independent equations. What we are going to do? Here we get identical system of equations. Then I have to choose two unknowns must be k1, k2, give the set of L1, 0, 0, 1, because I'm required only two eigenvectors. You already know that one vector is a 3 cross 3 matrix, therefore required 3 eigenvectors. Once we get eigenvectors, you find out the inner product, but x2, x3 is not, inner product of x2, x3 is not equal to 0, therefore you again apply the Gram-Schmidt. While taking Gram-Schmidt, only choose the non-orthogonal vectors. x2 is my v2, therefore find out v3 is based on only v2, not for v1 also. Okay, once we get, again you check it out v1, v2 with your orthogonal is orthogonal, then you have to write the orthonormalized columns vectors are nothing but p, and then as usual transpose you take, then p transpose into a into p, that gives us d diagonal matrix whose diagonals are what actually eigenvalues of the corresponding matrix A. The next one is actually is a given matrix. Whenever I want to find out the power of A, there how to find out? Suppose it's a symmetric matrix, this is a formula. What's the non-symmetric? This is a formula I told, p into d power of n into p power of t, and then transpose of p into d power of n into p inverse. But this matrix is not a symmetric, therefore find out up to till eigenvectors. Once you find out eigenvectors here, in this case directly write the columns of p is nothing but eigenvectors. Eigenvectors of each of the eigenvectors is nothing but columns of p, and then you find out p inverse using what about that Gauss-Jordan method. This method is called Gauss-Jordan method. Then you have to write p, and then you write the identity matrix based on the order of P. Using elementary row operation, you convert the P's identity matrix. Instead of identity matrix, we get a new matrix, that is our inverse. Then you have to multiply that. What is that? P inverse of A into P. P inverse of A into P, then you have to multiply that. Automatically we get diagonal matrix whose diagonals are eigenvalues of the corresponding matrix. How to find out A power of 4? A power of 4 is nothing but P into D power of 4 into P inverse. Just you take the diagonals multiplied by 4 times and then multiply it, we get A power of 4. Now I am complete my this one, what actually all three types of how to find out diagonalize. Symmetric, suppose eigenvalues are repeated, is a non-symmetric matrix. How to diagonalize? Now you take some more problems from the textbook or any Google article to solve it, and also you solve the model paper question papers and 2018-19. That's enough. Thank you very much for listening. I'll come and meet you in the next video based on new topic is nothing but quadratic form. Only two topics are left. One is a quadratic form, another one is SVD, singular value decomposition. Thank you very much. Bye. See you.